All right, let's dive into something that's really shaking up how we think about performance in the Java world, Micronaut data. It's a modern toolkit for database access, and it has a pretty clever trick up its sleeve. Let's get into it. So, if you're a developer, you've totally been here. You build this awesome lean microservice, but the second you add your data access layer, everything just slows to a crawl. The startup time tanks, and your memory usage just explodes. So what gives? Well, for decades, the reason has been pretty much the same. You see, traditional frameworks, even really powerful ones like Spring Data or Gorm, they do a ton of work when your app is starting up. They use this technique called runtime reflection. It's basically like they're reading and analyzing your code while it's running to build this giant map of your database entities. This meta model lives entirely in memory, and it just chews up resources and adds precious seconds to your startup time. That's a huge problem in the cloud-native world where we need things to be fast and lean. But what if we could just get rid of all that runtime work? What if we could shift it somewhere else? Well, that's exactly where Micronaut data comes in and completely changes the game. This isn't about what happens when your app is running. It's about what happens when you build it. The secret sauce here is something called ahead of time, or AOT compilation. The best way to think about it is like this. A traditional framework is like stopping your car at every single intersection on a road trip to ask for directions. It's slow, it's inefficient. AOT compilation, on the other hand, is like having the entire route calculated by your GPS before you even pull out of the driveway. All the heavy lifting is done up front, so the journey itself is just incredibly fast. I mean, that's really the whole idea right there. Micronaut data precomputes everything it needs during your build. It looks at your code, figures out what you're trying to do, and generates all the queries ahead of time. So what's left is this super thin, really lightweight runtime layer that just executes. No reflection, no bulky in-memory models. So what does this magic actually look like when you're writing code? You might be surprised by how simple and, frankly, how normal it looks. You just start with a simple interface, just like this. If you've ever used another data framework, this should look incredibly familiar. You've got a book repository, it extends CRUD repository, and you tell it you're working with book objects that have a long ID. And that's it. Seriously. At compile time, Micronaut data sees this and just wires up all the standard create, read, update, and delete methods for you. Okay, now for the really cool part. Let's say you want to find a book by its title. You don't write any SQL, you don't write an implementation. You just add a method signature to your interface. Book, find, string title. That's it. By just naming the method this way, you're giving the Micronaut compiler a direct instruction on what you want to do. And boom, here's what happens. During your build, Micronaut data sees that method name, and it generates the actual real SQL query needed to make it happen. This query gets baked right into your application, ready to go instantly. And here's the best part, it's completely type safe. If you had a typo in the word title or used the wrong kind of parameter, your app wouldn't even compile. It finds your mistakes before you even run the code, which is way better than finding them in production. And this isn't just for simple finds. This pattern, which we call dynamic finders, is incredibly powerful. You can build some really complex queries just by combining keywords in your method names. Want all the books with more than 500 pages? Find by pages greater than. Or how about finding all books created in a specific date range? Find by date created between. You're literally writing code that writes your SQL for you, safely and efficiently, all at compile time. Now, you might be thinking, okay, this is great, but is it locked into just one type of database? And the answer is a big nope. Micronaut data was designed from the get-go to be a flexible toolkit for pretty much any data store you can throw at it. So yeah, this isn't just for one kind of database. Whether you're in the traditional relational world with JPA and Hibernate, or you're working directly with JDBC or R2DBC, or even if you're in the NoSQL space with MongoDB or Azure Cosmos DB, Micronaut data gives you that same consistent compile time powered experience. You get the same awesome benefits no matter which backend you pick. Okay, so we've seen the how, which is super cool, but now let's talk about the why. Why does this compile time approach matter so much right now? Well, this is where all that technical stuff turns into real, actual benefits for you and your apps. First and foremost, speed. Just by getting rid of all that work at runtime, Micronaut applications can start up dramatically faster. And in a world of microservices and serverless that need to scale up and down in the blink of an eye, that is a massive advantage. When you put it side by side with traditional frameworks, the difference is just crystal clear. Micronaut data gives you way lower memory usage and much, much faster startup times. And that translates directly into smaller container images, lower cloud bills, and really snappy performance for things like serverless functions that have to deal with cold starts. So let's just quickly recap the big ideas here. First, Micronaut data uses the power of ahead-of-time compilation to move all the heavy lifting from runtime to your build time. Second, that gives you real, tangible benefits. We're talking faster startup and way less memory usage. And finally, it just makes for a better developer experience, with type-safe queries that catch your bugs at compile time, not at 3 a.m. in production. Which really leaves us with one last big thought. As our applications get more distributed, more fast-moving, and more demanding, that old runtime overhead is becoming a bigger and bigger problem. Micronaut data is showing us a different path forward. So the question really is, are we seeing a fundamental shift here? Is moving all this logic to the compiler the future for building high-performance cloud-native apps? It sure is starting to look that way.